In this module, we'll bring in some gates. We left our corridor structure after we figured out which parts are gateways and which are the corridors. In this clip, I want to create pivot points where I can place gates. To find them, I need to single out the corridor walls. This is now fairly easy, since I can just create a blast node and then ask for the attribute structure. Type in structure equals corridor and enable delete none selected. The whole process of the gate placement will take more nodes than that. So again, combine it into a subnetwork and I call it gates. Now inside here, we can display points and normals and take a look at the corner points. As you can see, the normals are still facing in the average direction. In the current situation, we need all of them to face in the same direction. The fuse node does the trick. Then I create another blast node, since I only need the points either on the bottom or the top. So type in @p.y equals 0, turn the blast node to points and enable delete none selected if you also choose the bottom points. Now to place a gate at the end of the corridor, we need to find the outside points, find the position between them and then create a new point. So let's jump into the editor and let's think about how we should solve this problem. Now we could once again use point clouds. We could use the cloud to test how many points are around the current point, because the outer points have one less than all of the others. But we already used that. We have a different and much easier option. I simply check if the color of the current point on the x-axis is lesser than 1. If I go back to the incoming corridor walls, you can see that the outer walls are not completely red because the outer primitives fused with the green gateways before. And similar to the averaged normal value, this also created an average color value. This allows us to bypass the whole process of either counting the neighbors or using a point cloud to find the corners. We can directly use the current position to create a new one by adding 2 times the normal value on top of that position. But keep in mind that our normals are facing outwards. That means we have to multiply by -2. Then simply use add point to create our new gate point. Hit apply and you can see in the viewport we have a new point exactly in the middle between the 2 corner points. Now for these new points, I also want to give them the structure attribute with the value gate. Then I also need a normal value on this point. So I also use the current normal value and set it for this one. But now when I deselect the point numbers, you can see that I not only have 1 point, I have 2 points, because I also had 2 corner points. But when I zoom out, you can at least see we now have points at the end of all of the corridors. We only need these new points for the gates, so let's get rid of all of the other ones. Since we gave them the structure value gate, this is easy enough. Ask for structure equals gate, set the blast to points and delete none selected. We definitely only need 1 point, so let's use a fuse node to keep only one of them. But this also deletes the normal. So let's get that one back by using an attribute transfer node and take the normals with us. As source, simply use the wrangle node where we created them and make sure that we only bring over the point normals. And as you can see, now we have 1 point with normals. If we template the corridor segments, you can also see that they are in the right place. But now we have the next problem. We need these points to have normals that face from the gateway into the attached corridor. But as you also can see, these normals are facing sideways, according to the corner point they were created from. We have to rotate that normal. So let's create another wrangle node. The gate points go into the first input, and as second input we use the corridor walls. After naming this wrangle, let's go into the editor. A good way to solve this would be an intersect. We're also going to use a cross product to rotate the normals. So we start like usual. We create the main variables we're going to use. An intersect variable, a test position vector, and the other vectors we need for the intersect. Then we set the current normal to the cross product of the current normal and a vector that points straight upwards. This rotates all of the normals by 90 degrees. But as you can see, half of them are pointing in the direction we want them to, but the other half points in the opposite direction. If I comment that last statement, you can see how the normal jumps back to its original state. So how does the cross product work? It takes the first vector in green and uses the second vector here in blue and builds a cross product by using the plane created from both vectors, and that product moves in an orthogonal direction from that plane. So that means our normal is either pointing into the corridor or into the gateway. So we need to find out which one is the case, and if it's the wrong one, we have to reverse the initial direction. Here comes the intersect into play. Let's create a new position, a test position that has the current position plus the normal value. In the end we will use this test position, but for you to see what happens, I will update the real position with this testing behavior. After I hit apply, you will see that the point jumps into the direction of the normal. Then we need another normal vector. This time this is only for testing purposes. We once again do the same thing. We build the cross product of the current normal and the up vector. Again, for you to see what that does, I put the result into the current normal. Now they point again in the direction of the corridor wall. The ones that I moved into the corridor will definitely hit the corridor, but the ones that went in the wrong direction will hit nothing. The intersect uses the second input data, the position and the normal times 3. I could be more precise and only use times 2, but I know with the multiplicator 3 I definitely reach the wall if it's there and there can't be anything else. So if the intersect variable is equals -1, I do know that the intersect hit nothing, which means that my initial cross product turned the normal into the wrong direction, facing towards the gateway and not into the corridor. So I just multiply the current normal by -1. Now, to make sure that this testing behavior does not interfere with my real normals and real positions, I use the test variables to make the second cross product and the intersect. And if you look at the points and their normals when I hit apply, you can see how they jump back to their original positions, and now all of them have the normals pointing into the corridor. And as a slight adjustment, I want the point to move just a tiny bit into the corridor. 0.1 of the normal value should do the trick. That will help later on when we place the gates itself.